everyone. Welcome to RC Plane Lab. I'm Ron.
I'm Tom.
Last week we talked about servos and how to correctly mount them. Remember, the eyelets go down
Against the surface, that you're mounting them to.
That's the biggest takeaway. If you took nothing else away from last week's episode, that is this.
Yes.
Eyelets go down. Now that you've installed them in your airplane, what's next? Hooking them up to your control surfaces.
That's the next logical step once you get them mounted into your airplane.
And then you get to go fly and play and have fun.
And then, the fun is just a short bit away. So, how about we start with the mechanical linkages that connect the servo to the control surface?
Okay, sounds good.
So, we have, so the connection sort of goes like this. It goes, you have your servo that is now correctly mounted in your airframe with the eyelets down against the
eyelets down.
Mounting surface.
Eyelets always down.
Exactly. So you have the servo arm next in the chain of vents that are going to take the motion from the servo to the control surface. Then you have the push rod connection at the servo arm. Then you have the push rod itself. And then you have another push rod connection on the control horn, which is then connected to your controlled device. And that could be either an elevator surface, an aileron surface, rudder, throttle arm maybe. I don't know. What else?
Bomb door opening.
Yeah, there you go. Yeah, bomb release mechanism, any kind of device that you want to control with your servo, that's the chain that we're talking about.
That's the endpoint.
Exactly.
So really quick, the arm, just for definition's sake, is the piece that goes on the servo.
Exactly.
And the horn is the piece that goes onto the control surface.
Right.
So if we say horn, we're talking about control surface side, and if we say arm, servo side.
Yeah, I tend to do that a lot. I just assume everybody knows when I say arm that they know I'm talking about the servo arm.
I don't.
So I apologize in advance if I say arm. But when I say that, I'm talking about the servo connection or the servo arm, and the horn is the control horn on the surface. So I apologize in advance if I just say arm, but that's what I mean when I say arm or horn.
Well, and that's why we talked about it now, to get that cleared up. So
Exactly.
we know. So since we're talking about arms, what is an arm?
So an arm is a device that's attached to the servo output shaft that basically transmits that servo motion into another motion that will physically move your control surface. They can be made of plastic. They can be made of metal. There's lots of different shapes and sizes. Usually I like to use the arms that come with my servos because usually they're designed to work with my servos. But there are certainly situations where, you might want to use an aftermarket or a heavy duty. You'll see lots of different types.
Also known as more expensive.
Yes, they are a little more expensive.
A lot.
The metal ones especially, which I don't buy a lot of those. So
Don't look at me.
you have some metal servo. Well, on the table,
you
I guess
also have some.
mine.
So you own more than I do.
Well, I have more airplanes than you do.
Oh,
I didn't
that's
mean
probably
that
the meanest thing you could have said to me. That hurts.
At any rate, like I said, they come in different shapes. You'll see arms with 4 legs on them, or 3 legs on them, or 2, or 1, or 6, and sometimes you see a servo arm that doesn't. It's not an arm at all. It's just a big wheel.
What do you mean by leg?
So let's say an arm that has 4 legs. It's basically looks like if you look at it, it looks kind of like a star. Has 4 points on it. I call each one of those a leg.
Oh, like a plus. Okay.
You know what I'm saying?
So a 4-legged one looks like a plus sign. A 2-legged one looks like a minus sign, a subtraction sign.
Yeah.
Okay.
And
or when it's rotated, I guess a 4-1 looks like a multiplication sign.
yeah, exactly. Yeah, right. Rotated.
X versus a plus.
Yeah, 45 degrees, I guess it would be. But yeah, so I call those legs. There are probably other names for them too, but a lot of people assume, and I did too for a long time that, let's say a 6-legged servo arm was in case you needed 6 connections to the servo. That's not exactly right. And we'll talk about this here in a little bit, but it allows you flexibility on how to mount that arm so that you can get it exactly centered where you want, and you get that leg exactly in the position that you want it in, which we'll talk about in a minute. But
really quick before we go any farther, again, too, with the different legs that are coming off, is there anything ever wrong with cutting them off if they get in your way?
Absolutely not.
Okay.
In fact, as a matter of habit, I do that. Just because,
you actually, okay.
Because I think it looks cleaner.
Okay.
I don't like having all those extra legs moving around whenever I'm, operating my control surfaces. So once I get my connections set and I get the setup right and I get the angles and the travel the way I want, I usually will cut off those extra legs because they're just not necessary. And I don't reuse them. Like if my airplane, heaven forbid, crashes, I'm definitely not going to reuse the servo arm. Because it may have taken, stress in a crash or whatever. So I'll just go ahead and the plastic ones from the manufacturers are pretty cheap. So I'll just put a new one on there. And I have, usually you get a nice assortment of them when you buy a new servo, and you save those, right? Because you don't throw anything away.
No, you might need it later.
Exactly. So
we all have hundreds of them.
Yeah, a wide assortment of them left over from the many years I've been doing this. So
many.
So I'll go ahead and pop new ones on there for
many years
for a new. I get it. I'm old.
You're the one that said it. I had to make sure to point that out.
But yeah, anyway, I'll put a new one on and trim off the legs that I don't need, just for a nice clean look. And then I probably go overkill. I'll get my Dremel with a sanding drum.
I was going to ask you about that.
Because
I could see you doing that.
Because
mine are all sharp.
Yeah,
don't touch it; it's going to cut you.
Yeah, if you cut off a leg with a pair of side cutters and it leaves those nasty kind of square edges, I'm not a big fan of that.
Well, see, I go one step farther. I will cut it off with a pair of side cutters and then cut each 90-degree angle down to 45, so it's rounded enough for me.
Okay, well, I'll actually go the next step and get my Dremel out with a sanding drum and make it nice and round and smooth. But
I am not surprised.
That's just me.
By any means.
So anyway, that's a servo. That's what a servo arm is.
Okay.
The control surface horn or the control horn, again, they can be made of many different materials. I've seen plastic. I've seen metal. There's also FRP, which is fiberglass reinforced plastic. Mm-hmm. I've seen fiberglass versions. I've seen carbon fiber ones. There's lots of different flavors. I've seen wooden ones actually.
Yeah.
Lots of different flavors, and they can be bolt on. They can be built into the surface. Lots of different styles and shapes and sizes. On. They can be glue on. Yeah. Exactly. In the case of our little foamies, sometimes they just press into the foam.
Yeah,
with a little hot glue. So lots of different shapes and sizes and materials, but basically it's a device that attaches to your control surface that allows you to make that push rod connection. So there you go. That's an arm and a horn. Those are the definitions. So let's talk about push rods.
You get way too excited about push rods.
Well, they're the thingy that connects the servo to the control surface. I mean, they're really, really important.
They are.
And they're just neat. There's so many different styles. You've got like the solid wire push rod that slides in a tube or not. Sometimes you can put holes in your airframe in your formers just the right size to run your solid metal push rod through there. I've done that. I do that for throttle a lot on my sport type airplanes. There's the plastic push rod in a tube kind of arrangement, which are pretty common and really, really easy to set up. One thing I don't like about those is with temperature, because the plastic shrinks and swells, it can change your trim.
Never thought of that.
Yeah. So I mean, if you fly in the same climate all the time, it's probably not a big deal. But here where we live, it
changes by
Illinois,
day.
It can be 20 degrees one day and 60 degrees the next day, and it actually does shrink and swell a little bit, and such that if you're a really good pilot, not me, but if you're a really good pilot, you can feel that trim change with temperature change. So, but anyway, I've used them. The plastic tube in a tube type push rods. Like I said, those are really easy to set up, and they look cool too. And they're really slick. They slide really easy. So there's wooden dowels. You can actually use a wooden dowel as a push rod. That's old school, but I've done it.
I've got a few airplanes that have that in it.
Yeah, SIG
older
is,
ones, but yeah,
SIG airplanes are they're common with those, and they work great. Basically, it's a piece of wooden dowel, and then on either end you take a piece of wire, put a 90-degree bend in it, and drill a little bit of a hole in the end of on the side, actually towards the end of the push rod, and that 90-degree bend kind of goes down in that hole, and you file maybe a little trough for that wire to sit in. To the push rod, and then you wrap it. If you really want to get trick, wrap it with thread, and then epoxy the whole thing together. It makes a really, really nice push rod. Actually, it's not real heavy. Same idea with the fiberglass push rods or arrow shafts. There's special devices that you can use to.
You mean like actual?
Yeah, like bow and arrows. Yeah.
Oh.
Arrow shaft. Yeah.
I was thinking AERO, like an arrow shaft or something.
Oh, I'm sorry. No,
like an actual bow and arrow using. Okay.
ARROW. Arrow shafts. I've seen those used as push rods. In fact, I think Sullivan used to sell push rods that way with a special insert that they made or that they manufactured that glued into the end of it with the wire sort of the threaded end sort of incorporated into that. And those are really popular too because they're really, really light. A lot lighter than the hardwood dowel ones. Yeah. So, so there's those. There's wire cables, like in a pull-pull type arrangement, which are really common with big airplanes. And even some smaller sport type airplanes are putting them on rudder, which is nice. It's a good setup. Mm-hmm. There's Kevlar thread in a pull-pull arrangement, same idea. Basically connection on either side of the rudder, with tension on both leads. Pretty slick setup, slop-free usually. Carbon fiber rods, actually, small diameter that have specialized metal inserts machined just for them. You glue them in, and then you have the threaded ends machined into them that you make your connections with.
That's kind of like the arrow.
Yeah, like an arrow shaft, but usually quite a bit smaller in diameter. And that type of connection is for shorter push rods on big airplanes, if that makes sense. We're not using a terribly long push rod, but you want something rigid between the servo and the control surface, and that's one connection you can make between those two types of surfaces. Same idea with a ProLink. It's basically just a turnbuckle is what I call it. It has left-hand threads on one end and right-hand threads on the other, and it threads into plastic clevises or plastic rod ends or heim joints. I think Dubro makes them, ball links or swivel links. Those are great for smaller, shorter connections.
Expensive.
They are
very expensive,
but boy, they're easy to install, and they're nice because they're turnbuckles. So if you turn it one direction, you can make that push rod longer, and you turn it the other direction, it makes it shorter. Yeah. So kind of helps with the setup, and for any trim changes you might need to make in the future, you don't actually physically have to disconnect it, which is kind of a neat deal. So that's some of them. I mean, there's lots of different ways to accomplish the task of connecting the servo to the control surfaces, but that's the many different types of push rods that you'll see out there.
So the tri-motor, everyone's going to be a pull-pull?
That's our goal. I mean, we wanted to kind of make it authentic, and I believe most all the control surfaces on the tri-motor are pull-pull. So we're going to have a heck of a time with that. That's going to be fun. Actually, I don't think it's going to be as hard as we're making it out.
It's going to look neat, though.
It's going to look really cool. So yeah. I'm excited.
Me too.
But yeah, pull, that's what we're going to use on the tri-motor, we think.
The plan so far.
Or at least a faux pull if necessary. Right?
I think they're all going to be pull.
Okay, then. Right on.
I mean, yeah. If we have it, all pull.
Okay, pull. There we go. He's
pull,
made the decision
all the way.
So let's talk about the connections the push rod connections that you make at the horn or the arm. Go ahead.
So what do you mean?
Scroll.
You mean the part that actually goes like from the push rod to like connect the push rod to the horn itself?
Exactly.
Or the arm, now that we know the difference?
Yeah. Yep, and it can be at either end. You can use the type of connection you can usually use at either end. So, for instance, I'll pick one, a plastic snap link. Let's say Goldberg used to make these. Dubro makes them. Snap. They're a plastic clevis. Sullivan makes these in a metal version, and it's basically just two metal or two tabs with a pin that connect the two that goes through the hole in the arm or the horn, if that makes sense.
It does.
Yeah.
How well do those actually work? Like, what's the longevity on those? Because the piece, like the actual plastic piece that goes between the clevis, I mean...
The pin?
The pin, there you go.
Okay.
That always seems like it'd be a failure point to me, like an easy failure point.
Yeah. So
Well, I got you off guard.
well, I've never seen one fail.
Oh, okay.
But I will caveat that by saying I take safety measures. I use some safety precautions, like especially when I'm using plastic clevises. And I'm talking about the snap together clevises like Dubro makes and Goldberg made, many years ago. And I think most ARFs, actually, sport type ARFs, will have that sort of a connection in the kit. I take a piece of fuel tubing, about a 1/4 inch long, and I slide that over those tabs. And then when I make my connection and I've got everything all nice and set up the way I want it to, I slide that piece of fuel tubing over those tabs to act as a kind of a
clamp,
a securing device. Yeah.
Yeah.
Now, some clevises have that built in. Like Sullivan, their metal ones, they have a key or a keeper
little
that
notch.
actually snaps onto the end of the pin once you've made the connection. And like I said, plastic or metal, I've never seen a pin fail.
Okay.
Now, I've seen them wrecked. Like after a crash, I've seen them fail then.
Yeah.
But me personally, I've never had one fail in flight.
Never cause a crash.
Right, exactly.
Okay.
But I could be that I'm just really, really lucky, or it could be that I don't fly as much as I should or fly as much as other folks, but
or as hard as you should.
But I do notice over time, especially the metal clevises like the Sullivan ones, they will over time, because we have vibration, no matter how careful we are with balancing our propellers, which we talked about before, we still have some vibration. And that vibration over time will cause that metal pin to wear out or elongate that hole in your plastic horn or arm usually, so that can set up slop over time. So that's something that, if you fly a lot, especially one airplane that you fly a lot, maybe that's your favorite, and it's set up that way, check those connections often for slop. And because slop can develop into flutter, and we all know flutter from
Flutter
one of
is
our
bad.
Yeah, from one of our previous episodes is not a good thing. So,
No.
So yeah, there's clevises, there's easy connectors.
Well, now hold on. With the clevises, like you have to be prepared for using a clevis because you have to have a threaded end,
Exactly.
And a matching threaded end, by the way,
Right.
because there's multiples.
There's different sizes. Yep.
Yeah, on the push rod.
Yep. So there's here in the U.S., we are on the Imperial system, so we use 256 and 440. Those are probably the most common clevis thread sizes. In the everywhere else in the world that is on the metric system, I think they're 2 millimeter. I think 2.5 millimeter, something like that. But yeah, you have to use a matched setup. So your push rod end, like either end of your push rod that makes the connection to the servo or the control surface, arm or horn, has to be ready to accept that. So usually it's a threaded end of some kind. On our larger airplanes, sometimes I've seen 632, which is up there around 3 millimeter, I think. And actually 632 might be closer to 3.5 millimeter. But either way,
I'm not sure.
you have to have a threaded end, unless you're using Z-bends, which we'll talk about in a minute, or easy connectors.
I've never seen threaded or a Z bend on that size.
On what size?
Like 3/8 or not 3/8, like 1/8 inch or
no
3/8 is huge.
Yeah, usually Z bends we're gonna be at the 256. There are Z benders out there that will bend 440. your hole in the servo arm has to be so big at that point that I would worry about risking the integrity of the arm. But yeah, so you have a clevis or some of these other, like a Heim joint or a swivel link or whatever.
What's a Heim joint? I've never heard of that.
It's another term for a ball end. Yeah, so you know what a swivel link is. A Heim joint is just basically another term for that. It's a captured ball in the end of a plastic eyelet.
Oh, so the same thing, but just another name.
Yeah, it's just another name for it.
Is that like a brand name? Or like...
I don't know. Huh. I know it's used in the automotive world. They call them Heim joints. I know they use them like on at the end of a turnbuckle, like on race cars. They have the threaded rod end. They call them Heim joints. I don't know. Maybe it's just a universal thing for that setup. But anyway,
I don't know.
It has to thread onto something. So the end of the end of your push rod has to have threads that are ready to accept that. Like I said, there are different types of threads. Here in America, we use the Imperial system, and more often than not, you're going to find 256, 440, or 632 on really big applications. So that's the clevis, right?
Okay.
So a swivel end or a ball joint or a swivel link, I think Dubro calls them swivel links. They act kind of the same way as a clevis, but instead of snapping onto the control surface, they actually bolt to the control horn or arm. They actually use a bolt with a nut on the backside, a much, much more secure connection that on some manufacturers is actually adjustable for wear over time, which is pretty slick. Dubro makes some swivel links that have I believe it is a 256 bolt that goes through the farthest, outermost end of that rod end that you can actually kind of clamp down as that ball wears into the plastic, which is pretty slick. That way you don't have to replace the end. You just give it a quarter of a turn to tighten
it up.
Yeah. So, but it's the same sort of connection. It threads onto the end of your push rod and then makes the connection to your arm or horn via a through bolt. It bolts actually to the arm with a nut, usually on the backside for safety. So, same type of connection, just a little bit more secure, and definitely gonna last longer. So, my least favorite connector. And Ron's favorite connector.
As the name implies.
Oh, I hate these things. Easy connectors.
You know why I like them?
I don't know. Because
they're easy.
They're easy. Yeah,
I mean, they really are.
They are. They're
I know
very
you've
easy
had
to set
issues.
up.
Yeah, I know you've had issues with them, and you've chided me for many years for using them. However, as we have said, I don't know how many times before, know your application.
Right.
And I would not use them on a bigger balsa airplane. I would not use them on anything that I consider important to me.
Or sentimental. However, anything that is simple, anything that is cheap, anything like profile foamies or anything where I want to be able to adjust it if I need to, man, they are perfect. Yeah.
And they're cheap. Really?
Yeah, they're really not that expensive.
All things considered, they're not very expensive at all.
They are super, just like the name implies. They are super easy to set up.
Yeah.
But there's a few things that I'm not real fond of about them. Like I don't want to poo-poo them altogether because they do serve a purpose. Like on our foamies, on our little they're perfect for those.
I know, and that's what I mean. So know what you're doing with them and know your application, and I have no problem with them.
And I really like using them in that application, but I like even on a 40-sized sport plane, I won't use them. And here's why.
I have.
I know. I have too. I'm guilty of it. I've used them, but here's why I don't like them. So if you're not familiar with what an easy connector is, it's basically a bushing that more or less just pokes through the hole of your servo arm, and then it has a plastic snap
Not all.
device.
Some are metal.
But most of the ones I've seen have a plastic device that just basically presses onto the other end of the pin, and that is the connection to your servo arm or control horn if you're using them on that end. I have a problem with anything that is just press fit because vibration over time is going to probably loosen that up.
Okay, however, now I'm going to defend the ones that I bought last because they came with both the plastic ones that you're talking about
Right.
and the metal clips. Now, the metal clips that go on it, they're not E-clips. They're, where they go on from a side, but they're a full, it's like a full capture thing to where it has the, what do you call it, the little ears that go around the notch inside of that little doohickey that comes out of the pin. And then that's a good connection.
Yeah,
you are not getting that off. Sorry, hold on. You are not getting that off without breaking that clip.
Absolutely true.
Because I've had to do it before.
Yeah.
And you cannot pull it off without breaking it. So I don't think that's accidentally going to come off in flight.
No, probably not.
But the plastic ones might. But the metal ones will not.
Usually the ones that I've had experience with are not exactly, the pin is not exactly the right size to make it through the hole in the arm and make a really nice solid connection. More often than not, the hole in the arm is too big, either because I've drilled it out too big or because it was molded too big or whatever. So that pin is not a nice, I don't want to say tight because you don't want any friction, but it's not a secure fit in that hole.
Snug.
And it wobbles. And that causes inconsistencies with, especially if you're using it for throttle, maybe, you may have 10, 15 degrees of stick deflection on your throttle and you'll get no movement at your throttle because all that movement is being taken up by the slop in that pin in the hole. That drives me nuts.
I can understand that.
Okay, so that's one of the other reasons I don't like them. And then the big one, and this is the big one for me. So describing an easy connector, it's this big, it's a metal device that pins and otherwise attaches to your servo arm or control surface, and it's got a hole drilled through it to accept a smooth wire rod, which is your push rod, and then it uses a set screw
which makes it infinitely adjustable
to then clamp the rod within the easy connector, and that is your connection to that control surface.
Most of the times, now not all of them, but most of the ones that I've seen, the end of the set screw actually has a little bit of a gouging mechanism or whatever you want to call it that will actually eat into that rod a little bit and makes a pretty good connection for small airplanes.
I've had them fail.
That you don't care about.
Granted, but I've had them fail. And
I'm not saying you haven't.
And I've even gone to the extra lengths that, probably most folks don't, is to grind a flat spot on the push rod where that set screw bears down like you're supposed to do with, with any set screw. And I've still had them, and when I say fail, I shouldn't say fail. I mean slip. Yeah. Slip maybe.
Yeah.
So I'm not a fan on larger models, but on our foamies, man, they're perfect. They're perfect for that application.
Once again, know what you're putting them in and be fine with losing it just in case.
Like Dubro makes a heavy duty version designed to accept a 440 rod. That's a pretty big push rod that you're probably not going to put on a foamy.
Well, like I said, personal choice. Everybody has their own thing they like to use, and I will use them for cheap ones.
Yeah, and I still will too. For my foamies, for sure, because they make the setup so easy, and they're super easy to use. But know your application. Easy connectors for foamies, thumbs up.
All right, so what's next?
Well, what's next is really kind of my favorite servo connection because I fly a lot of, most of my models are sport balsa, not real big, not real expensive because, airplanes, if you have a lot of them, they tend to get pricey. So Z-bend is probably my favorite one, and that's what's next. And you know how you accomplish a Z-bend?
Well, you use...
It's time for RC Plane Labs Tool of the Week.
The Z-bend plier.
Yep. Yeah, we got one right here on the desk.
We have two. Right,
we actually do. That's right.
One's yours, one's mine.
But yeah, every modeler who wants to build, sport balsa airplanes should own a pair of these. They're really not that expensive.
No, they're not. But here's what I like about them.
Super easy to use.
Not only are they easy to use, but it's one less failure point
Exactly.
when you're hooking up a control surface.
Yeah, that's exactly right.
And the nice thing about it is, too, it's cheap. Like, really, if you're going for something inexpensive,
Yep.
the best way and most inexpensive way to do it is to use a Z-bend on one end and then whatever else you want to use on the other end. Using the Z-bend, though, it's captured. It can't come out without breaking.
Yeah.
And, I mean, you don't have any issues with it not working the way it's supposed to.
Exactly. So I'll describe what a Z-bend is. It's basically a Z-shaped bend in your wire push rod.
Man, it's like they were brilliant when they named that, right? Gosh.
So if you can picture it, you're sliding your servo. Let's say we use them. I like to use them at the servo arm.
Actually, really, it's not. No. Sorry, it's not actually a Z-bend. After you said that, the more I started to think about it.
Oh yeah, it's true.
It's not really a Z.
It's really more like an N. Well, it's not even an N.
No, it's not an N. It's a 90-degree angle and then another 90-degree angle.
That's true.
So it's like a plateau.
Yeah.
But anyway.
Or a step.
It's even better.
It's a step bend.
A step bend.
Yeah.
Well, I'm disappointed now.
Yeah.
But it kind of looks like a Z if you don't know how to make a Z very well.
That's true. Like maybe if you're a second grader. Maybe what a second grader would.
Maybe they should know how to do a Z. But anyway, we'll go back to Z-bend because that's what they're called. But it's not really a Z.
No, it's not. It's two, like you said, it's two 90-degree bends basically opposite each other or 180 from each other.
Yeah.
So I like to use them on my servo end because it cleans up the installation in the fuselage. Then I don't have a lot of, clevises or easy connectors, just kind of moving about in the fuselage.
I like it on the other end, by the way.
You like it at the control surface?
I like it at the control surface because then it looks better from the outside.
Oh, no, I get that. Yeah.
It's less hanging out from the back of the airplane.
Sure. I like it on the inside because then my clevis is on the outside. So if I need to make an adjustment to the airplane, I don't have to pull the wing off and get into the fuselage to the radio to make an adjustment. I could just turn the clevis right there at the surface and make my adjustment. But, I totally get the cleanliness. I had not thought of it that way, but yeah, I may set him up like that.
I just blew your mind.
You did. Because I'm all about cleanliness.
I know. That's why I said it.
But anyway, it's just it's, as we established, it's two 90-degree bends. And if you can imagine, you take your servo arm, sometimes, and this is where slop, where we want to try to avoid slop whenever possible, we usually have to bore the hole in your servo arm to accept the rod, the 256.
Almost always.
So the drill bit I think I use for that, don't quote me, I think it's a number 38. I think. Actually, that seems like it might be too big. At any rate, find a bit that is just the right size to drill that hole and give you a nice friction-free but no slop fit into that hole. And you basically just slide the arm over the first 90-degree bends, make it flat, and you're ready to connect it to your servo. And because I like things clean, I'll usually set my bend so that the extra wire is underneath the arm, if that makes sense.
Yeah, I do the same thing.
Yeah.
If I can.
Right.
Otherwise, I put it to the inside of the airplane.
Exactly.
So it's by the fuselage.
Right. And then on the other end, you make whatever connection at the control surface or the servo in your case that you like. But they're super easy to use and very, very secure. Just like you said, you don't have to buy any extra stuff to do it. You've already got the rod there. Just put a quick Z bend in it and you're ready to go. You're ready to move on to the other end.
I had one, I've never had a problem doing them before, but I had one rod that I bought. Anytime I did a Z-bend in it, it would just break.
Oh, really?
I would come with 3 pieces.
It was tempered or something.
I don't know what it was.
That's
but it was an actual push rod because it had, one side was threaded.
Oh, I'll be darned.
But yeah, it kind of upset me because I had to throw it away.
I've run into that too. I've been trying to make a throttle push rod or whatever, and I'll, get out my pair of pliers and make a 90-degree bend. And I've had them break before too. Yeah.
Weird.
It is weird. I wonder if that's a tempered. You don't want to use tempered rods. Use the mild annealed steel alloy rods like Dubro makes and Sullivan and the other companies.
Yeah, that way they're still pliable and not brittle.
Right. And because they're pliable, they're less susceptible to breakage from vibration. Mm-hmm. So there you go. Yeah. Z-bends. Love them.
Me too.
What's next?
Solder links.
Solder links. That's a little bit different. That's something that you're basically adding threads to the end of a non-threaded rod via a solder-on link. So basically, if you can imagine, it's a short piece of brass usually. The half of it's threaded, and the other half is just an open, not an open hole, but it's a a bored hole in the end of it, designed to slide over your 256 rod, let's say, for example, and then be soldered in place. So then you now have threads at the end of your push rod.
Almost like a plumbing joint.
Exactly.
Yeah.
Yep.
I've never used one of those.
I've used them. They work pretty well. You have to be okay at soldering. Because that's definitely a failure point that you want to try to avoid. So
I wouldn't think that would be too difficult, though. Like
It's not.
soldering something small like that would be fairly simple.
Yeah, and they're like
As long
once
as it's hot enough.
Yeah, once it's soldered, you rough up the end of the rod. Once it's soldered, and if it's soldered correctly and it's not a cold joint, they're very secure.
Yeah,
it's not
they're not
something I
going
want to
anywhere.
use all the time, but on my my balsa airplanes, my Sport 40 size airplanes, I'll go to those occasionally.
It's a little time consuming.
It is.
I mean, compared to a Z-bend.
But so I'm cheap. So I have a lot of leftover 256 rod with no threads on it at home. So if I need a quick push rod and I don't want to drive 2 hours away to the hobby shop to get one, I'll solder one of those on, and now I've got a threaded rod.
Yeah. That's a good idea.
Yeah, I've used them, and they work pretty well. They do tend to get heavy because that's a big piece of brass at the end of your push rod. So if weight is a concern, I mean, granted, it's not adding a large amount of weight in the grand scheme of things, but they are heavier than a standard steel rod of the same length or a plastic fiber or plastic or fiberglass push rod. So
Yeah.
solder links, I've used them. They work pretty well. And then probably the most secure connection, which I mentioned a little bit ago, are
Secure, and most expensive.
Yeah, they are. So swivel links, and these come in many, many different sizes. Like I think you can get them all the way down here in the U.S. anyway. I know you can get them down to 256, but you may be able to get them smaller now too. I'm not sure. But they are very, very secure. And the nice thing about them, like I mentioned earlier, is that some of them are actually adjustable for wear over time. And what a swivel link is, it's just a captured ball, basically snapped into a plastic housing that's round like an eyelet, and then it has threads on the other, or internal threads on the other end to be threaded onto the end of your push rod. And then these are made to be actually physically bolted to the control horn or the servo arm. So very, very secure. And they can get expensive, but man, they're really slick.
Especially when you add them up. I mean, when you talk about the whole thing that goes together, because that goes with the turnbuckle.
Right.
That's what you use those on most of the time.
Most of the time. Yep.
And that adds up when you got to do two of them and the turnbuckle and everything for an expensive servo.
Right. Now,
but
I will
it's
say,
worth doing it because that's the best way to do it.
For sure. I will say I think on my Duelist, I actually used them on one end of both my elevator and rudder push rods because of the wonky kind of angle that the push rods came out on my build. Mm-hmm. I didn't want to put a bend in the rod and potentially weaken it. So to kind of take up that angle, because they do swivel, I think up to 15 degrees or so, I think most of them.
Yeah.
I was able to make that connection at the control surface with a threaded rod. And I only needed a package of 2, because I only used them on one end of each one. And guess what's on the other end?
A Z-bend? Yeah. I am not. That's what I used on mine too, is a Z-bend.
Yeah.
And a clevis, because I went simple.
Yeah.
So the thing about all these, though, is they're not all interchangeable.
Oh, that's exactly right.
Not every connection is appropriate for every situation.
Yep.
So you wouldn't use like a Z-bend to make the connections on a giant scale airplane. No. You wouldn't use a heavy-duty ball link on a foamy. There's right ways and wrong ways to set everything up, and we should want to do it the right way.
Yeah.
So how do you know what to use where, or how do you set them up in the most efficient way possible? Yeah.
So I have some rules that I use, but for starters, so when I'm setting up control surfaces, we'll mention things like throw, and that basically is just a very general term that refers to the amount of surface deflection or travel. Kind of all those terms are sort of interchangeable. So, and then I'm also going to talk about evenness, which is really, really important because for consistency across the entire range of travel or control surface deflection, that travel's got to be even in both directions. Now, there are exceptions. Sometimes we want differential throw. Like, for instance, some trainer type airplanes, you want more up aileron travel than down to counteract, adverse yaw or bad, not bad, but
Aileron, really?
yeah, sometimes. Yeah, we used to add aileron differential mechanically way back in the day to ailerons because of the adverse yaw. When you'd move the stick one direction, it may want to yaw the other direction because of the increased amount of drag because of the descending aileron caused rather than does that make sense?
Yeah, no, I got you.
So
now.
sometimes we would want to set them up so that they would have more up travel than down travel.
I've seen it on elevators quite a bit where you want more up elevator than down.
Right. But generally speaking, it's better to set everything up even so that they are exactly the same and so that they reach those endpoints at the same point or at the same, I'm not sure if time is the right word, but in the same arc or the same...
same rotation?
Yeah. So
same degree,
right,
I guess,
exactly,
of throw?
Yeah,
okay.
Exactly. So that means that setup, the setting up your control surface linkages and everything it plays an important role in proper control surface movement. Like I said, we want everything to be even, and there's more to it. There's more to installing your radio and setting up your servos and your linkages than just getting the control surfaces to go the right direction. So a little bit of work in the setup of your control surfaces pays big dividends in an airplane that flies consistently and does exactly what you want it to do no matter which direction you go with the stick, if that sort of makes sense.
Makes sense to me.
It's like tuning. I mean, you build a race car, you're going to have to tune the engine. You build an airplane, you're going to have to tune your control surfaces, and you want to start with a nice, even setup from which to tune.
Now, I don't want to get it's cool to talk about this, but I don't want to scare people away. This is getting into it a lot more than most people would. Whenever I've set up control surfaces and throws and all that kind of stuff, I will do it correctly, but I have never tuned an airplane like that after I've been flying it. Yeah. Not saying I shouldn't, not saying I couldn't, but I'm just saying I haven't, and I haven't had issues.
I haven't either.
Yeah, so as a beginner, if you're flying pretty much any over-the-counter type airplane, I would say, if you're not doing competitions, you're not doing any kind of, IMAC or any of that kind of stuff, you're not going to notice really anything. So this is good to know, but don't get scared away because of it.
Yeah,
I think I wanted to just kind of make that.
Yeah, and I don't want to get too far into the weeds because even me, I spend all this time on tuning and setup and stuff. I'm not a good enough pilot probably to feel an airplane that's not tuned, perfectly. But just because I won't notice a difference doesn't mean I don't enjoy spending the time to get it exactly right because I'm a bit of a perfectionist when it comes to stuff like that. So I want to set it up right. And hey, someday a buddy of mine that is a really good pilot might want to fly my airplane, and I would be embarrassed if somebody flew my airplane and thought, oh, this guy doesn't know what he's doing. So I try to set him up right.
So what you're saying is I should never let anybody else fly my airplanes.
I'm not saying that at all. I flew your airplane and it flew awesome.
Now you've made me self-conscious.
Perfect. Mission accomplished. Uneven throws, in a nutshell, in your mechanical setup, can cause, affect further tuning, like dissimilar exponential curves or, dissimilar dual rates or EPAs. If you don't have exactly the same travel left or right or up and down of center, that affects other tuning later on down the road. So bottom line, we just want a nice, even setup from the start. And the way to do that is with a deflection gauge. I mean, that's the easiest way to do it. Just get yourself a relatively inexpensive deflection gauge. There's many of them on the market. If you start with an even setup, then, a nice even, you've got 27 degrees of travel to the left. Make sure you have 27 degrees of travel to the right. And you'll be rewarded with an airplane that responds the way you want it to. And then if you get really good eventually, and you really want to start exploring the limits and the fine tuning, you'll at least have an even setup from which to start.
Okay, so you said you use certain rules to set these things up. What are your
Tom's
rules?
rules. I have lots of rules, which is weird.
Oh, I mean, what are your rules for this?
Okay. So these are my rules. I'll just caveat this whole conversation that's about to happen that these are the rules I use. They work for me. They've worked for me for a long time, and they actually work for you because this is kind of the advice I give you too whenever you ask. So here we go. Rule number one, proper servo centering, right? So we talked about in our last episode using the
Servo tester.
Servo tester. You can also use your radio system, but make sure your trims are neutral and the sticks are neutral. Turn everything on, let everything go to its center point. I'm talking about everything but throttle, and then turn everything off. Turn the radio off, or the receiver side off first. That way nothing moves when you turn the transmitter off. And now you have the perfect center. Okay, so the servo's centered. Now we want to make our connection.
Hold on, before you go, I like what you said there about how to do that, but my issue with doing it that way is, have you ever tried to hook up a servo that A, has no power to it, so it's not trying to stay centered, and B, has no way to keep itself centered? So it's very easy to knock that out of center and not know that you did that.
It's true.
So that's why, for as cheap as those servo testers are, like I said, it was a 3-pack for next to
they
nothing.
Were cheap,
that is, to me, the only way to do it because it's so much simpler. You don't have a lot of electronics sitting out, and you're centered the whole time.
And it will hold it there while you're attaching your linkages and making your adjustments and stuff. Yeah. Good point. Yeah, because when you turn everything off, the servo now is susceptible to movement. You can physically move it off of its center. But anyway, proper servo centering, get that servo centered, and then the connection that we make at the servo ideally will form a right angle. Okay, so you've got your push rod coming to the servo, and it connects to the servo leg, right? That connection, that push rod to leg, if you want to draw a line from the output shaft out to the point where the push rod actually connects to that leg, you want that as close to 90 degrees as possible. That way, we're talking about evenness again. So that way, your left travel is going to match your right travel because you've got it set up at a 90-degree angle. Now,
so that way, the arc, when you go, I don't want to say negative, but when you move the servo one way, the arc is the exact same movement, same degree as it is if you go the opposite way.
Exactly.
Because if it's not 90 degrees when you start, then that angle is going to change more going one way than the other.
Yep.
Okay, I'm following what you're saying now. Sure.
And if you wanted to picture that on a round servo wheel, that's akin to mounting the connection off center from that arm. And then what does that do for us? Well, that was a mechanical way we used to set up differential throw. And differential throw, by definition, is
different,
more one way than the other way. So we don't want that. We want a nice, even amount of travel left and right or up and down. So we want that to be as close to 90 degrees as we can. And there's a couple of ways you can do that. So like we mentioned, the servo arms have different legs on them. Sometimes you may need to pop that arm off, rotate it to the next leg, and if it's not the 90 degrees that you wanted with one leg, rotate that thing, and usually you can find one leg on that arm that will give you the 90 degrees.
Now that's for multiple off-degree arms. So if you have a two-legged servo arm. So if you have a two-legged servo arm, you're not going to be able to get that odd angle out of it. So it's going to have to be one that's like a odd number of legs. So like a 5 or something.
Well, that's not exactly true. So I've had them be 180 out like that before, and rotating. It's weird. I can't explain it, but because of the odd number of splines that are on the output shaft, when you take that servo arm and rotate it 180 degrees, sometimes that will give you the between tooth alignment that you need. Sometimes, not always.
Forget I said anything, and let's move on.
But more often than not, 180 gives you the exact same results. But try it. If that doesn't do it, then grab one of the other arms that came with your servo, so long as it's enough to give you the travel you want, and find a leg that at neutral makes that 90-degree connection. So that's rule number 1. So rule number 2, longer push rod lengths are usually better than short ones. And this is this is really nothing more than spreading out wonky angles over a longer distance. It minimizes their effect on everything. So if you can imagine, if you have a really short push rod and you rotate your servo through 120 degrees of rotation from one side all the way over to the other, you notice that angle is going to get extreme as it gets to its outermost limits. If you take that push rod and make it longer, it's less extreme.
I understand now.
Yeah.
Which is odd because, just from a top-down perspective, I guess, I would think it would be the opposite because you would have the possibility to have more play in it. Right. If you don't have a strong enough push rod, you're going to be able to get more vibrations or what in it if it's longer. So
longer. And like I said, these are my rules. I usually try to go with longer push rods. And if you have the option, you can, sometimes if you want to make them longer, you can mount the servo in a different position or a different location. In the case of an ARF, sometimes you can rotate the servo 180 degrees in the mount to get the output shaft farther away from the control surface so that you can use a longer push rod. And most of them are actually set up that way. I've seen ARFs that are not set up that way, and then they don't give you push rods long enough to make the long push rods. So then I'm fishing through my stack of push rods and soldering on it. And anyway, longer push rods, generally speaking, are better than shorter ones. That's rule number 2.
Okay.
Rule number 3. So I try to make it so that my connection on the servo side is as close to the output shaft as possible, and on the control surface side as far away from the hinge line as possible, while still giving me the total amount of travel that I want. Okay.
So that's for more torque?
So what I'm doing here is I'm taking advantage of the mechanical leverage that my servo has that I paid so much money for. I want to make sure I'm using up all of that resolution and all of that torque that I'm able to get. Like, the farther out you move on the servo arm, generally speaking, the less torque you're able to get out of your servo. So, and that also plays with all the other aspects of your servo, like your centering ability and how precise it is and all these other things. The closer you are into that output shaft, the more precise the control is and the more torque you get out of the servo. So you want to obviously get as much travel as you need. Don't set up your control surfaces so that you have more travel than you need, because then you're using up that adjustment and you're using up resolution that you have in the servo. So
that makes sense. I get that.
Yep. Shorter at the servo side and longer at the control surface side, if possible.
And don't try and do 45-degree deflection on airplanes that don't need it, like a duelist, like I did.
Exactly. Yeah. Well, I mean, I was flying your duelist and I was using quarter of stick maybe, and that thing was rolling plenty good. So you have resolution that you're giving away on your servos because of the mechanical setup. So get as much deflection as you want, right? But don't set it up so that you get more than you need, because you're giving away resolution on your servo. So shorter at the servo arm, longer at the control surface.
So I'm hearing I need to redo mine.
Yes. So that's rule 3.
Agreed.
So rule number 4, mount the horn. Okay, now we're talking about the control surface. Mount the horn where it needs to be so that you get even deflection. And that doesn't always mean that the hinge or the pivot point is directly in line with the hinge line. That is a rule of thumb that a lot of folks use, and I do too. And that's a good starting point, like to set the pivot point of the arm directly above or below the hinge line.
Yeah.
But that doesn't always yield even a distribution of throw, because sometimes it depends on how your servo is mounted. And this usually happens on our larger airplanes where we have like elevator servos mounted, in the horizontal stabilizer. Because of the angle and everything that the servo is mounted, we're not able to attain that 90 degrees square that we're talking about on the servo side. So, we may have to make up for that by offsetting the pivot point from the hinge line. So
there's a lot of geometry that goes into it.
There is a lot of geometry.
Yeah.
And another good use for the deflection gauge is this point here. A lot of times you can, and so I'll try to make this short. Sometimes I have tack glued like the nylon control horns to my control surfaces to be able to manipulate them through the range of motion to make sure I'm getting evenness before I settle on a point where I want to actually mount it to the control surface.
Before you drill?
Exactly.
Okay. It's a good idea. I'd never done that before.
Medium CA sticks good to Monaco, but also pops off pretty freely and allows you also to then, drill it and mount it. But anyway, mount the horn where it needs to be to give you even deflection. Don't just stick it above the hinge line, especially if you're really into precision. Don't just stick it above the hinge line, because you may or may not get evenness that way. So you mount it where it needs to be mounted. Don't mount it where everybody just tells you to mount it. And that brings us to rule 5. Pay attention. You mentioned geometry. Pay attention to geometry. This is really, really important with 3D setups because of the amount of deflection that we're talking about. Some, you said 45 degrees. Some of the 3D setups are that much or more. I don't fly 3D. I'm not very good at it. I probably don't fly enough to get good at it, but that doesn't mean I don't pay attention to the geometries. And by geometry, I'm talking about like the plane of travel, right? So on an aileron, let's say you have your servo mounted in the wing, like most aileron servos are mounted these days on our balsa planes. The plane of rotation from the servo is actually offset from the plane of rotation of the actual control surface.
It's 90 degrees off.
Right, exactly. Mm-hmm. So if, for example, let's say we used really, really short control horns and that angle gets really, really wonky at either end, then we could potentially run into binding or unevenness or lots of bad things, bad angles, like for instance, a swivel link that's outside its range of motion is going to cause binding and stress and things like that. So you want to pay attention to the geometries and run these things through their complete range of motion before you settle on a position for mounting the servo or setting up your push rod or what have you. It's just something that you have to pay attention to. Don't just slap your servo in there and hook up the control rods the way they are in the pictures of your manual and then expect it to work. More often than not, it's going to be just fine. But know that there are limitations to every installation, and geometries play a big part of that. Obviously, if you're dealing with something that's operating in the same plane, it's less of an issue. But definitely, like on our ailerons, on our bigger airplanes, that can be an issue. So we don't want to set up any binding, and we certainly don't want to develop any slop, which brings me to my 6th and final rule.
Finally.
Avoid the slop, right? I mentioned a little bit earlier that easy connectors, can wallow.
Introduce slop.
Waller out the hole, and then you've got weird setup there. Just avoid the slop whenever possible. You want to make your connections as tight as possible.
Snug.
But you also don't want them to bind.
Yeah.
If you're going to use Z-bends, for example, make sure that the hole you bore in the arm or the horn is exactly the right size. You don't want it too tight, and you definitely don't want it loose because that's going to develop slop. Also, another little trick I use is if I can get away with it, I will make the connections on both the arm and the horn as far away from the center line of both of those as possible, as long as I can still get the travel I want. And the reason for that is it lessens the effect of slop. So let's say we've got them connected.
So just to make sure, you use the farthest out hole that you can use?
If possible, yes.
Oh.
Yep. And what that does is any slop that might be present in the system, the farther out you go, the less effect it has on the overall system. Like if you can imagine having the push rod connected really close to the servo, any slop in the servo connection there is going to, say, develop into 3 to 4 degrees of movement at the control surface. Whereas if you move it out and that you increase that distance, it gives the angle less arm, if you will, to actually move that surface. So you may go from 3 to 4 degrees. If you're mounted inside, you move it out, you may only get a degree or so. So, and then that was one more thing I wanted to mention. I forgot to mention it earlier. Ratio. It's not really a rule of mine, but I try to make it so that my ratios are not 1-to-1. Why are you smiling?
Well, because you said you were finished, then you threw a thing on it, even though it's not an actual rule.
Okay, how about a general guideline, number 1A, or something like that?
There you go.
General guideline number 1A. There we go. So ratios. So the distance at the servo, let's say from the center of the output shaft to my connection point, let's say that's 1/2 inch. And let's say my connection at the control surface from the center line or from the hinge line to the connection point is also 1/2 inch. 1/2 inch to 1/2 inch, that's a 1-to-1 ratio. I try to avoid that whenever possible. Number one, because I usually don't need that much travel. But number two, because I'm potentially leaving resolution on my servo on the table. So usually I'm making it such that the ratio is more like in favor of the servo. So it might be 1-to-2 or 50 to 70 or whatever that is. I try not to make that 1-to-1. And the reason for that, again, is just resolution. I want to get as much resolution out of my servo that I paid for. And if I go 1-to-1, I'm leaving that on the table because I've either got too much travel that I don't need. Therefore, I'm using up those steps in the resolution that I don't need, or it's setting up some potential for slop or something like that. So I try to avoid 1-to-1.
Makes sense. Never thought about it, but that makes sense.
So those are my rules and my general guideline 1A for how I set up my servo connections. Hope that was helpful.
Yeah, hopefully it was. We'll
By
see.
and large, if you build an ARF according to the instructions, you're going to be just fine. But if you really, really like to tinker, like me, time spent in the workshop pays dividends on a model that flies the way it should and maybe better than one that was not cared for as it was assembled.
Why did you look at me when you said that?
I don't know. I didn't mean anything by it.
Oh, you're so... Anyway.
We do need to adjust the controls on your Duelist, though.
Yeah, we will. Before we fly it again.
Cool. I've got some adjustments to make on mine, too.
Yeah, I want to make mine faster than yours.
Like new engines.
What?
Nothing?
Are you serious?
No.
Did you really get new engines for it?
No. Why would I do that?
What did you get?
I didn't get anything.
Oh, gosh. Okay.
I have engines.
Why would you? You were so like fawning over these Irvine things, and they were like, I don't know, the perfect thing ever. So you're not changing them?
I'm hunting for 110 now. I want to hit 110 mile an hour with that airplane.
Oh, my. I just want 100, so.
Oh, you're there easy. A few little tweaks and you're over 100, I bet.
Oh, I would be, yeah.
So, okay. That's all I have for servo setup and installation. Hopefully you've found this interesting and not too boring, but I did get into the weeds there. But spend some time in the shop, get the servo set up just right, and you'll have a really, really good flying airplane.
Fun. Anything else?
That's all I got.
All right. Then until next time, I'm Ron.
I'm Tom.
Good night.
Good night.